For number 3, you also want to determine the nature of the solution. Is it one solution, no solution? Are they the same line? And in order to do that, you want to change them to slope-intercept form, but you're not even going to have to go that far. As soon as you figure out the coefficient on the x, you should recognize that this will have one solution. So I would divide both sides by 6 to determine what the slope is going to be. And this one's going to have a slope of 1/6 on that x. You do not need to finish this because once you check this one, you will see that the slope, when you divide both sides by 10, means that you'll have 1/10 x. So the slopes are different, which means that there is going to be one solution. In the last problem, we plugged the y value in as a way to substitute, but here, both of these are already solved for x, which means I can set them equal to one another. So I have x is equal to 6y plus 7, but that's also x is equal to 10y plus 2. So they must be equal to one another in order to figure out where they intersect. I'm going to remove 6y. These add to 0. And 10 minus 6y is 4y. Then I'm going to remove the 2 from that side. And those add to 0, which means I have 4y equals 6. To solve for y, I divide both sides by 4. And y is equal to 6 over 4. But if you reduce that, it's 3 over 2. Then we need to plug it back in. I would choose one of those original equations. I'm going to use the top one, but if you use the bottom one, it should come out the same. So wherever I see a y, I replace it with 3 over 2. All right, and then multiply. 6 times 3 is 18. And 18 over 2 can be changed into a 9. And 9 plus 7 makes 16. We need to rewrite our x and our y coordinate as a point. So our solution is 16, 3 over 2. Again, you need to graph them. I am not going to do that, but your homework does ask you to graph them, so make sure that you do that